The Big Bang Theory is the most accepted explanation for how the universe began. It suggests that the universe started from a single, incredibly hot and dense point. This point then expanded rapidly about 13.8 billion years ago. Before the Big Bang, there was nothing. No space, no time, no matter. Scientists use models and observations to understand this event. They study cosmic microwave background radiation, the afterglow of the Big Bang. This light provides clues about the early universe. The Big Bang wasn't an explosion in space, but an expansion of space itself. Everything in the universe today was once packed into that tiny point. As it expanded, the universe cooled, allowing particles to form and interact. In the first moments after the Big Bang, the universe was incredibly hot and chaotic. Temperatures were so high that no atoms could exist, only particles like quarks and electrons. This period is known as the Planck epoch, lasting only a fraction of a second. As the universe expanded, it cooled, allowing protons and neutrons to form about 1 second after the Big Bang. Around 3 minutes after the Big Bang, temperatures dropped enough for protons and neutrons to combine, creating the first simple nuclei. This period is known as nucleosynthesis. For the next 380,000 years, the universe remained a hot, dense plasma. During this time, nuclei and electrons couldn't combine, making the universe opaque. This period is known as the photon epoch. Light couldn't travel freely, creating a cosmic fog. At about 380,000 years after the Big Bang, the universe had cooled enough for electrons to combine with nuclei, creating the first true atoms. Most of these atoms were hydrogen and helium, the simplest and most abundant elements in the universe. This period is known as the era of recombination. During this era, the universe became transparent, allowing light to travel freely. This light is what we now see as the cosmic microwave background radiation. The formation of atoms was crucial for the evolution of the universe. These atoms began to clump together under gravity, forming denser regions. Over time, these regions grew larger and denser, setting the stage for the birth of stars and galaxies. As light moved freely, it carried energy away, allowing the universe to cool even more. This cooling process was essential for the complex structures that would later form. The era of recombination marked a significant turning point in the universe's history. As atoms formed, the universe transitioned from an opaque plasma to a transparent state. This period allowed light to travel freely for the first time. The cosmic microwave background radiation we see today is a relic from this era. During recombination, small fluctuations in the density of matter began to grow. Gravity pulled matter towards these denser regions, leading to the formation of the first structures in the universe. Over time, these structures became the seeds for galaxies and stars. The universe continued to expand and cool, allowing more complex atoms and molecules to form. These new elements would later play a vital role in the formation of planets and life. The era of recombination set the stage for a universe filled with light, matter, and the potential for complexity. Section 5. The birth of stars and galaxies. With the universe now transparent, the stage was set for the birth of stars and galaxies. Small fluctuations in the density of matter began to grow under the influence of gravity. These dense regions pulled in surrounding gas and dust, eventually forming the first stars. This period is known as the cosmic dawn. The first stars were massive, hot, and short-lived, playing a crucial role in shaping the universe. Their intense radiation and powerful winds influenced the formation of subsequent generations of stars. These early stars also produced heavy elements through nuclear fusion, scattering them into space when they exploded as supernovae. Galaxies began to form around these early stars, creating gravitational bonds that held them in place. Over millions of years, these clusters grew larger, forming the first galaxies. Section 6. The role of dark matter. Dark matter played a crucial role in the formation of stars and galaxies. While it doesn't interact with light, it has a significant gravitational influence. Scientists believe that dark matter makes up about 27% of the universe's total mass and energy. Its presence helped shape the universe's large-scale structure. Dark matter clumped together in the early universe, forming dense regions called dark matter halos. These halos provided the gravitational pull needed to draw in normal matter, leading to the formation of galaxies. Without dark matter, it's unlikely that galaxies would have formed as quickly or as efficiently. Observations of galaxy movements provide indirect evidence for the existence of dark matter. Understanding dark matter is one of the biggest challenges in modern astrophysics. Section 7. The formation of the solar system. The formation of our solar system began about 4.6 billion years ago. It started with a giant molecular cloud, a cold and dense region of gas and dust. This cloud began to collapse under its own gravity, forming a rotating disk. The center of this disk became the sun, while the rest of the material formed the planets, moons, and other objects. The process of planet formation is known as accretion. Small particles of dust and ice stuck together, forming larger and larger bodies. These bodies, called planetesimals, collided and merged, eventually forming the planets. The inner planets, like Earth, formed from rocky materials, while the outer planets formed from gas and ice. The young sun emitted strong solar winds, shaping the composition of the planets. Section 8. The early Earth. Earth formed about 4.5 billion years ago from the dust and gas left over from the solar system's formation. Initially, it was a molten mass of rock. Over time, Earth cooled, forming a solid crust. The early atmosphere was composed mainly of hydrogen, helium, and volcanic gases like carbon dioxide and nitrogen. Earth's surface was bombarded by asteroids and comets, which brought water and other essential elements. As Earth cooled further, water vapor in the atmosphere condensed to form the first oceans. These bodies of water became crucial for the development of life. The formation of the moon also played a significant role in Earth's development. The moon's gravitational pull stabilized Earth's axial tilt, leading to a more stable climate. Section 9. The development of Earth's atmosphere. The development of Earth's atmosphere was a gradual process. Initially, the atmosphere was composed of gases released by volcanic activity. These gases included water vapor, carbon dioxide, nitrogen, and sulfur compounds. The early atmosphere was thick and toxic with little to no oxygen. As the planet cooled, water vapor condensed to form oceans which absorbed significant amounts of carbon dioxide. The emergence of photosynthetic organisms about 3.5 billion years ago marked a significant change. These organisms, like cyanobacteria, use sunlight to produce energy, releasing oxygen as a byproduct. Over millions of years, this oxygen accumulated in the atmosphere, leading to the Great Oxygenation Event. The increase in oxygen levels allowed for the development of more complex life forms. Section 10. The emergence of life on Earth. Life on Earth began in the oceans with simple, single-celled organisms. These organisms thrived in the nutrient-rich waters and evolved over time. The early oceans were a chemical soup containing the building blocks of life. Through complex chemical reactions, these molecules formed the first living cells. The evolution of photosynthesis was a critical step in the development of life. Photosynthetic organisms transformed the atmosphere by producing oxygen. This oxygen allowed for the evolution of aerobic organisms, which use oxygen to produce energy. The increase in oxygen also led to the formation of the ozone layer, protecting life from harmful radiation. Life moved from the oceans to land, leading to the evolution of plants, animals, and eventually humans. Section 11. Summary. From Big Bang to Earth. The journey from the Big Bang to the formation of Earth is an epic tale of cosmic evolution. It began with the explosive expansion of the universe about 13.8 billion years ago. This event set the stage for the formation of particles, atoms, and eventually stars and galaxies. The formation of our solar system about 4.6 billion years ago marked a significant milestone in this journey. Through the process of accretion, dust and gas formed the sun and planets, including Earth. The early Earth was a hostile environment, but it gradually transformed into a habitable planet. The emergence of life on Earth was a remarkable event, evolving from simple, single-celled organisms to complex life forms. The journey from the Big Bang to Earth is a story of transformation, adaptation, and resilience. Understanding this journey helps us appreciate the complexity and beauty of the cosmos.